in number 11, the denominator of this rational function is a difference of perfect squares, and so that will factor as x plus 3 times the quantity x minus 3. The numerator is just a constant, -9, so there are no factors that cancel, which tells us that there are no holes in this graph. Okay, to find the equation of a vertical asymptote, we set each factor of the denominator equal to 0. So x plus 3 equals 0 and x minus 3 equals 0. So subtracting 3 from both sides, x equals -3 is going to be a vertical asymptote that we can sketch on the graph. And then if I add 3 to both sides, x equals +3 is also a vertical asymptote on the graph. Okay, then to find coordinates of zeros, I take the numerator and I set that equal to 0, but there is no x in that numerator. It's just a constant, and -9 would never equal 0. So there are no real zeros, no x-intercepts to put on the graph. Okay, coordinate of the y-intercept we find by putting 0 in for the x values in the equation. So we have a -9 divided by, and then 3 times -3 is -9, which is equal to 1. So 0, 1 is the y-intercept, and we can plot that with a closed circle on the graph. Okay, oblique or horizontal asymptotes, Bobo Batten eats DC. This one is degree 0 in the numerator, degree 2 in the denominator. That would be bigger on bottom 0, right? Bobo Batten eats DC, the Bobo bigger on bottom 0. So y equals 0 is the horizontal asymptote. If we plot that on the graph, right, that gives us that picture. Okay, then we need some extra guide points for sure, because we don't know very much about where this curve is shaped. So if we put in a 2 for the x, then we have a -9 over 2 plus 3 times 2 minus 3, and that would be -9 divided by 5 times -1 would be a -5, and 9/5, if we look for a decimal approximation, that would be 1.8. So 2, 1.8 would be around here. Okay, then -4, when we put that into the graph, or into the equation to find a point for our graph, -9 divided by -4 plus 3 times the quantity -4 minus 3 would be -9 over -1 times -7 is a +7. So -9 divided by 7 is about -1.285, so about -1.3. So we come over here to -4 and down to -1 1/3, and we'll plot that point. And then at +4, we put in 4 for our x's, so 4 plus 3, 4 minus 3, and that is another -9 over 7, or -1.3 approximately. So we come over here to 4, down to -1 1/3, and we can see that this has y-axis symmetry, so it's an even function, so I can reflect this point over, and that would stay inside the asymptotes, turn through that relative minimum, and then back up along the asymptote. And then these two sections are going to be along those vertical asymptotes through the turning point, and then there's our approaching the horizontal asymptote. So that would be a rough sketch of our graph for -9 divided by the quantity x squared minus 9. The domain, we have two vertical asymptotes breaking up the domain, no holes to worry about, so we're going from -infinity to -3, union -3 to +3, and then 3 to infinity. The range, we're going bottom to top, so -infinity, and we have to stop here at that horizontal asymptote at 0, and then we don't pick up again until we reach this relative minimum here, which is inclusive, so we need a bracket. That relative minimum is at 1, and then the graph heads up to +infinity.